Okay. So let's say, everyone, can you hear me or not?
Yes.
Okay, good. So, mana ni tak keluar lagi. Do you see anything
Yes.
in your screen?
Ada screen iPad.
Screen iPad, kenapa tak keluar lagi?
Yes.
Okay, good. Okay, so let's say, here. Okay, 28. Okay. So let's say if you do have 28 meter per second square and you want to convert it to kilometer per hour square. Okay, so look carefully. 28 meter per second square. So meter wants to convert it to kilometer. Okay, while second square is for hour square, because time to time, meter to kilometer means length to length. Okay, length cannot be transferred to, cannot be converted to time. Okay, so that's simple analogy. So whenever you want to do it, make sure that you put the top to bottom, meaning that you must have a numerator, okay, numerator yang belah atas over a denominator, like that. Okay, so times with something set. Okay, apa yang dia nak tukarkan tu tak penting. Sebab yang kita tahu, okay, cuma kita faham, meter mesti nak tukar kepada kilometer. Okay, so meter nak tukar kepada kilometer, tutup kurungan. Okay,
1/1000.
so bila meter kat sebelah atas, okay, kita letak meter kat sebelah bawah juga. Kenapa kita letak
Nanti boleh potong.
dekat sebelah bawah?
Nanti
Sebab apa?
Boleh potong.
Yes, correct. Sebab kita boleh potong atas dengan bawah. Kalau kiri kanan saya dah cakap tadi, tak boleh potong. Sebelah-sebelah tak boleh potong. Tapi atas bawah matematik ni matematik ni. Okay.
So atas kilometer.
1 kilometer. 1 kilometer. So macam tu. Right. Tapi kalau ada orang dia fikir cara kompleks, dia boleh juga jadi macam ni. Contoh kali dengan sebab dia di kilometer dengan meter tu akan maintain. So dia saja-saja dia. Saya pun tak tahu macam mana kenapa. Dia akan tukar, sorry. 0.001 kilometer over 1 meter. Pun boleh juga. Sama juga. So dia masih lagi, yang penting kita nak potong meter dengan meter. So kalau square pula, okay, square ni dia special sikit. Bila buat square, jangan pedulikan apa-apa square ataupun kali 3, kuasa 3 tu tak perlu pedulikan dia. So yang kita faham, dia nak tukar second kepada hour. So second kepada hour, so second is
atas.
Obviously saya suka pakai 3600 second over 1 hour. Second tu letak kat luar.
Sekuasa 2.
Letak kat luar bracket. Okay, so bila kita potong S square dengan S. Okay, dengan S square. Tapi ingat, kalau dalam kurungan, okay, so ni 28 so nanti end up dia 28 kali dengan 0.001 kilometers, okay, kali dengan apa? 3,600 square. Okay, kenapa? Sebab don't forget about
kurungan.
Macam ni. Kalau A, B square tu dia akan dapat apa? Dia akan dapat A square, B square. Correct. A square and B square. So over dengan, so bawah ada 1 kali dengan 1 hour square. So that will be, so inilah baru you tekan calculator. Tapi kalau kata yang atas ni sama hopefully semua orang faham. Kenapa saya gunakan yang ni boleh, yang ni pun boleh. Okay, sebab yang atas ni yang penting di dalam kurungan ni, you must have a correct conversion, correct conversions. Because 1 kilometer is equivalent to 1,000 meters. Okay, 1 meter equivalent to 0.001 kilometer. It's the same thing. Okay, Adam?
Okay, thank you, sir.
Okay, great. Okay, anyone else want to ask anything regarding? And of course, I want to highlight in terms of significant figures and significant figures. Okay, if you do have 0.36, how many significant figures?
2.
Ada
2.
Okay, yes, this is 2 significant figures. If you have 1.535, how many significant figures?
4.
4.
Correct. This is 4 significant figures. Very good, very well, everyone. Okay. So the significant figures, why we need to learn the significant figures and also the decimal point. Okay, so in terms of significant figures, this 0.36 is 2 significant figures and 1.535 is 4 significant figures. So how about decimal point? Okay, so for 0.36, how many?
2.
Yes, the 2 decimal point. And how about 1.535?
Ada
3
3.
decimal point.
3, sir.
3 decimal
Yes,
points.
this is 3 decimal points. So meaning that if you want to look at the significant figures, we look at everything inside the number, because but we should know that Dr. Ikwan already mentioned about the trailing zero and the leading zero. Okay, the leading zero maybe is not really important in the decimal point. Okay, the decimal means nombor yang ada titik perpuluhan. Okay, nombor yang ada titik perpuluhan. Of course, the decimal point here, what I want to mention is if 0.36 have 2 decimal point, meaning that dia ada di belakang dia ada 2. Now untuk decimal point 1.535 will have 3 decimal point. So what is the significant, ataupun saya tak nak guna significant lah, what is the importance of learning significant figures and decimal point? First, okay, you must know that the significant figures, okay, ingat betul-betul dengan ayat saya ni. Okay, the significant figures only occurs in this chapter only. Okay, while for other chapter nanti, bila chapter, the next chapter, maybe chapter 2 or chapter 3 or maybe chapter 4, and the rest of the chapter, we did not do much in terms of significant figures. Kita tak bother dah significant figures ni macam mana. Kita dah tak peduli kan. Tetapi kalau dalam untuk chapter ni, kita akan pakai ni. And then bila you see the questions, contoh soalan dia suka tanya. Okay. Ini soalan yang berbentuk significant figures. Okay. So given mass 0.35 gram. Okay, and volume 1.47 milliliter. Okay, so calculate soalan dia. Calculate the row. Apa dia row? Apa row? Apa?
Density.
Correct. It's a density. Okay, calculate the density. So what is the formula of density? Density is a mass per unit volume. Nampak tak macam mana saya nak mula jawab soalan? Saya akan tulis dulu equation. Saya tak terus tekan calculator. Okay, so that's what you should practice. Okay, when you come to the university level, always buat apa tulis equation. No, equation is very important for you to memorize. For you to, at least as a physicist, kita kena tahu bila masa nak guna all these things. Okay, so the density, mass per unit volume. So how about mass? Mass is 0.35 and 1.47. Now, obviously, this is the division. Okay, this is division, pembahagian. Okay, operasi dia pembahagian. So, kalau ikut video Dr. Ikhwan, dia bagi tahu significant figures only akan ada significant ataupun only ada kepentingan bila dia berlaku dekat mana? Berlaku dekat multiplication ataupun division. Ini tak nampak pula. Tetapi kalau decimal point, dia akan berada dekat adding, addition or subtraction. Okay. So ingat, di sini kita nak pakai yang mana? Okay. Tengok tadi awak ada 0.35 gram and 1.47 milliliter. Okay. So, how to do it? Okay. So saya kata apa? Bila nak calculate density, okay, we use a mass over volume. So mass over volume, kita pakai operasi apa? Operasi dia ialah operasi division. Division duduk dekat mana? Duduk dekat significant figures. So significant figures yang macam mana kita kena consider? Okay, kita tengok balik. Mass ada how many significant figures? 2. Okay, and volume, okay, is 3 significant figures. So in order for us to understand the concept of significant figures for this kind of questions, so kita akan ambil significant figures yang paling kecil. Ataupun okay, tak apa, no problem. So kita akan ambil 0.35 divide with 1.47. Okay, I know this is not the correct SI unit. Sebab apa? Sebab satu di dalam gram, satu di dalam mililiter. So tak salah sepatutnya kena dalam kilogram per liter. Okay, so saya pakai 0.35. Wow, siapa ada calculator cuba tekan belajar fizik ni kena ada calculator dengan kamu. So the answer should be lebih kurang 0.2381. Okay, saya round off kan dekat situ gram per milliliter. Betul tak?
Betul.
Okay. Okay, so berapa jawapan yang diterima? Berapa jawapan yang boleh diterima untuk jawab soalan ni? Okay, kalau saya jawab 0.381, okay, saya jawab 0.3323, sebab soalan dia nanti calculate the density of the object that that follows the significant figures. Maksudnya dia suruh follow significant figures punya method.
Sir,
Macam mana sih? Yes.
bukan masa density tu kena tukar apa? Unit tu ke? Gram kepada kilogram, mililiter ke liter.
Betul. Tu saya cakap tadi. This is not the correct unit. I just want to show you the calculation dulu. Okay. Calculation dia, maksud dia ini unit dia gram per milliliter. Obviously density is should be kilogram per liter. Dan kena tukar lah nanti. Okay, but I just want to show the calculation. So 0.238, kita tengok betul, 0.2381. How many significant figures?
4.
Yes. This is 4 significant figures.
4.
Jadi, yang mana kita nak, sebenarnya jawapan ni nak ikut yang mana?
List significant.
Balik.
List atas.
Correct. So, kalau kita tengok dalam soalan, the question give you 2 and 3 significant figures. So, the least one should be
2.
2 significant figures.
0,
Okay?
2,
It should be 2.
So
So
0.
jawapan dia sepatutnya kita kena tulis apa?
0.24
0.24
gram
gram per
per milliliter.
milliliter. So that should give you the answers that have a correct significant figures. Itulah maksud dia. Maksud kalau orang jawab 2381, salah ke? Salah lah, kalau ikut soalan ni salah lah sebab dia tak ikut significant figures. But that is not the problem when you come to other chapters. Maksudnya bila buat chapter lain, let's say masuk chapter 2, chapter 3, kamu dah tak perlu follow yang ni dah. Kamu buat macam biasalah untuk for the purpose of this chapter only.
Okay.
So that's why I want you to understand. Maksud dia tiba-tiba dapat soalan pertama dalam test nanti, dia minta kamu suruh cari area. Pelik tak? Soalan masuk soalan fizik, tiba-tiba dia suruh cari area. Oh, kamu pun tekanlah calculator. You do punch the calculator, you put the value. Oh, dengan handsome-nya jawapan betul. Tapi bila dapat jawapan, kenapa salah jawapan saya? Okey, nampak? Soalan pertama, tiba-tiba keluar area. Tak masuk akal. Sedangkan kita tengah belajar pasal significant figures, pasal converting units, pasal benda-benda lain. But whenever they come, tiba-tiba datang pasal area. Tak masuk akal So soalan-soalan macam tu sebenarnya soalan perangkap, soalan trap, soalan nak suruh kamu beware of the least significant figures. So you must remember, if you actually come to the situation where the first questions, the first ever questions, okay, asked by us, occasionally it becomes a really what an easy questions. Okay, macam soalan ni lah, density. Density kamu dah belajar ke? Maybe lah belajar dah sekolah tapi as I said to you earlier, this is like a new things to you. So density tak belajar lagi. Tiba-tiba tanya pasal soalan density. Oh, kamu pun ingat. Lagi best kalau soalan tu tiba-tiba dia bagi equation dalam soalan tu. Okay. So tiba-tiba the density is equivalent to mass over volume. So find the density. Jaga-jaga kamu pun jawab 2, 3, 8, 1. Dah yakin dah jawapan dia betul? Salah. Sebab you don't follow the significant figures punya rule. So you remember one thing about significant figures, make sure you do it correctly. Okay. In fact, for the rest of the chapters, kalau ni sebab kita dah terbiasa, we only answers the final answers like a 3 decimal point. It's enough already for the other chapters. But for this this kind of chapters, you must follow the significant figures. And of course, if you want to follow the significant figures, make sure it involve the multiplication and divisions. If the operation is addition or subtraction, tambah dengan tolak, kan? In that one dia akan follow the least decimal point. Okay? Itu yang saya nak highlight kan. Jangan pergi follow significant figures pula. Kalau situation dia tambah, kalau situation dia tolak. So tambah dengan tolak dia follow decimal point. Okay? Kalau untuk significant figures dia akan follow multiplication and divisions. Okay? Are you clear?
Yes, sir.
Any more questions?
Clear.
Okay, very well. Very
Sir,
good.
Sir, kalau ikutkan soalan
Yes.
macam ni, kalau contohlah soalan dia macam tu, kita kena tukar unit tu baru kita tukar pada significant figure. Kalau ikutkan
if the question asks you, biasanya kalau untuk soalan macam ni dia tak adalah test kamu. Mungkin most probably dia akan minta tukar kepada, dia dah bagi siap-siap unit yang betul lah. Maybe dia saja-saja bagi unit yang salah. Bukan unit yang salah, unit yang bukan SI.
Lepas tu kena betulkan, lepas tu tukar kepada significant figure.
Correct.
Sir, satu lagi soalan.
Yes.
Contohnya kalau soalan tu ada dua-dua multiplication dengan plus minus kan? Nak guna yang mana? Nak guna yang significant figure ke decimal point?
definitely if that involve multiplication and addition, maksudnya dua-dua sekali but in one questions, so definitely you must follow the mathematics rule lah. Maksudnya you do the part where the multiplication first and get that answers. That answer should be significant figures, and then you do the plus one, and that plus should follow the decimal point.
Okay, thank you.
Okay, Adam. Okay, anyone want to ask the questions? You still get.
Sir,
Ya,
yang
dah.
yang decimal point tu ambil yang list juga kan, yang terkecil.
Di list juga. Yes, list juga. List decimal point List
Alright.
decimal point maksudnya bilangan point yang belakang tu berapa? Paling sikit.
Okay, thank you sir.
Okay. We'll come back the words. Okay. Now, sekejap. Takut ada soalan lagi. Saya takut. Okay. I think that should. I think everybody have already understand the concepts of unit conversions. I want to highlight also about the dimensional analysis. Okay, so what is the main things that you want to know about the dimensional analysis? So taken here. So let's look at this problem first. Can you see it? Okay. This is the questions about show that the expression of x equals to x naught plus v naught t plus half at squared is dimensionally correct. Okay. So let's stop the presentation. We go back and we do present. Okay. Dimensional analysis. What does it mean by dimensional analysis? Can anyone give me a very solid reason what is dimensional analysis? Minta maaf tulisan saya buruk sikit. What is dimensional analysis? For those who have watched the video, do you know what is the dimensional analysis? What is dimensional analysis to you? Apa yang you faham pasal dimensional analysis? You want to try it?
Is it the calculation of
Mhm.
macam nak tahu whether something is dimensionally consistent?
Okay. Good try, Adam.
Okay.
Okay. If you notice, before dimensional analysis, we learned about basic quantity. Okay, so what is basic quantity? Quantity asas kan? So we have length, we have mass, and we have time. We also have temperature, and we also have current. So this is base quantity. You have 5 altogether. So if you notice here, length, the SI unit for length is meter, the SI unit for mass is kilogram, the SI unit for time is seconds, and the temperature is what? Everybody? What is the SI unit for temperature?
Kelvin.
Kelvin. Why we bother about Kelvin? Why don't we just stick to the Celsius?
Absolute temperature.
Original.
Conflict. And if you notice, if you are using Celsius, you must put degree Celsius, but not Kelvin. Kelvin is just 300 Kelvin. If you put a degree Kelvin, then you are wrong. You put 300 Kelvin, 100 Kelvin, 100 degrees Celsius. Why you need to put degree Celsius? And do you know that 100 degrees Celsius
Same.
is actually not the same thing as 100 Celsius degree.
Oh,
Ada cara nak tulis dia tu. It's not bukan masuk dia. Okay, saya terangkan. 100 degree Celsius is the temperature. Okay, dan maksud dia temperature pada 100 degree Celsius. Tapi 100 Celsius degree, bukannya saya typo tu, bukan saya tulis. Tapi dia menunjukkan apa? 100 degree Celsius menunjukkan this is the delta T. What does it mean by delta T? Change in temperature.
oh.
Equivalent to 100 degree Celsius. 100 Celsius degree. So maksud dia, perubahan. Kita ambil yang final, kita tolak initial, dia dapat 100. So 100 tu kita tulis 100 Celsius degree. But ramai orang tak tahu pasal tu. But it's okay. Yeah, you just stick to 100 degree Celsius pun dah memadai. Maksud saya nak cakap, as a physicist, kita tengok sampai benda tu sekali. Maksudnya kalau you belajar chemistry, it doesn't bother lah kan, dia tak kisah pun. Lebih kurang sama je. Tapi kalau dalam physics, degree Celsius and Celsius degree are two different thing. Tapi dia masih lagi merujuk kepada benda yang samalah. Okay, and how about current? We use ampere. So yang ini kita excludekan dulu sebab kita akan belajar later on current and temperature, dan kita akan lebih kepada LMT, length, mass and time. Okay, length, mass and time. So that's why dimensional analysis, a lot of dimensional analysis will involve L, M dengan T. Itu yang Dr. Iqbal masukkan dengan LMT. Okay, what is the length, mass and time? This length, mass and time can be derived. Okay, tahu daripada base quantity, you can do a lot of other equations that is equivalent to derived quantity. Sebab tu nama dia kuantiti terbitan. Kuantiti yang telah diderivekan. Tapi derive daripada siapa? Derive daripada base. Yes. Base apa? Length, mass, time. Mainlah dengan base time. Contoh saya ambil velocity. Okay, V is equivalent to length over time. Kan? Sebab tu nanti dia dapat length apa dia? Mass meter over second. Velocity ni nanti kalau dia ada direction. Kalau tak ada direction, kita panggil dia speed. Tapi kadang-kadang speed dengan velocity ni orang salah anggap sama je lah. Okay, so speed ni without direction, velocity is with the direction. So mass pula meter over second. Sebab tu dia punya unit dia m per s. Tapi kalau acceleration, the value will be the length over time times time. So that will give you m over s times s. So that is equivalent to meter per second square. So that's why the unit here acceleration is meter per second square. So our job right now, tadi saya bagi tahu is what is the functions of dimensional analysis. Adam said that you want to see the consistent. What does it mean by the consistent? So we want to check. Okay, check the equations. Okay, check the equations whether is it consistent or not consistent. Kadang-kadang kita panggil dia sebagai inconsistent. check the equation whether is it consistent or not consistent. How to make sure that the equation is consistent? So this is the examples. I'm using Dr. Equals Me example, which is x equivalent to x naught plus v naught t plus half a t squared. Pernah tengok ke equation ni?
Pernah.
Pernah.
Seriously
Nah.
pernah?
Kat video.
Okay. No, apart from video. I think I mean
tak.
from your school days.
No.
Tak pernah?
Pernah.
Oh.
Pernah?
Wait.
Pernah.
Tak.
Okay, agak-agak betul ke pernah? Because I also teach as tuition. I think
Ni
I'm not
kesaran
seeing any kind of equation like this.
Ini macam
Tapi dia dah
Sasaran.
macam mana?
Sasaran.
Jadi kurang je.
Okay, kalau dekat sekolah, kalau dekat sekolah equation dia macam mana?
V
Ni
equals to betul?
D ya.
D dia.
S
Okay.
equal to apa atas.
Yang macam pilih 1.2 kuasa 2 tu je.
S equals to UT plus
Baru nampak.
ada nampak benda yang persamaan? Macam
Ada.
mana bawah ni?
Titik
Macam mana
kosong.
yang bawah ni boleh jadi atas macam ni?
Sebab X tu distance, sasaran distance juga.
Tapi ada satu je S tu. Kenapa X dekat atas tu ada dua?
S dengan
Sebab
U.
tu sebelum awal distance
Okay.
awal.
Laju awal.
So
Distance awal.
okay, very good. It's okay. Right. So dengar. S yang masa sekolah dulu dia pakai satu sahaja. Tapi kita dah faham dia ialah sesaran. Sesaran ni what does it mean by sesaran? Kamu akan belajar next chapter. Okay. But sesaran ialah titik akhir tolak dengan titik awal. Titik akhir tolak titik awal. Tapi sesaran zaman sekolah dulu dia just bagi tahu sesaran je. Sesaran jarak kan, jarak tu daripada titik ini sampai titik akhir. Kan? Tapi kalau sesaran dia ambil titik akhir tolak titik awal. Okay, so asal dia sesaran ini sebenarnya ialah X tolak X naught.
Sesaran tolak sesaran.
Apa itu?
Distance
Apa itu X? X ialah titik akhir,
titik akhir dan
X naught ialah titik
awal.
awal. Yes. So kalau equation dekat atas tu saya ubah, dia akan jadi yang ni, equation ni saya ubah dia akan jadi X tolak X naught equivalent to UT plus half AT squared. So sana saya ambil yang ni, saya pindah belah sini. X equals to X naught plus UT plus half AT squared.
Oh.
So it's the same thing. Cuma kita perkembangkan dia because nanti later on awak belajar tajuk projectile, awak belajar tajuk motion, dia akan significant. Sekarang ni dia tak significant sangat lagi. Okay. So alright. So kita just nak make sure ini consistent. So lagi satu, saya gunakan V naught. Okay. Sama juga macam U naught. U tu ialah initial velocity. Okay, betul U ialah initial velocity. So sebab tu dia gunakan U. Zaman sekolah dia guna U. Di sini kita banyak guna naught. Naught tu bermaksud dia initial point. X naught. What is X naught? Initial position. V naught. Initial point. T naught. Initial time. So macam tu ya. Okay. So sekarang macam mana kita nak check? Maksudnya kita faham equation ni memang dah betul lah. Macam mana kita nak show dia equation dia betul ke tak? So how to show the equations whether the equation is correct or not? The equation is already correct. How to prove it that this equation is correct? So we must use the dimensional analysis. Because the dimensional analysis will show tadi saya cerita pasal ni the consistent and check the equation. Yang pertama check the equation, yang kedua the dimensional analysis okay, will show the units of parameter. Maksudnya kita nak cari apa SI unit dia, apa unit. Contoh, kita nak cari apa value untuk A. Contoh dia, okay, sama. Kita buat dulu yang pertama. Okay, nak check dia consistent atau tak. So first, X equals to X0 plus V0 T plus half AT square. It will be good if you can try it together. Maksudnya depan awak ni pun awak cuba buat sama-sama dengan saya. Okay, so X, what is X? Ingat dalam sistem dimensional analysis, we only use L, M dengan T sahaja. 3 sahaja. Okay, 3 jenis ni je. Jangan pergi tiba-tiba ada K ke apa, tak ada. Okay, it's just L, M and T. So X is length. So definitely dia akan gunakan L. Okay, nampak di sebelah kiri ialah L. Hopefully everybody masuk dia. Kalau kita gunakan ini, maksud dia yang merah ni semua sekali, tak boleh satu pun. Semua sekali mesti jawapan dia L juga. Kalau salah satu term, okay, di sebelah kanan tiba-tiba tak dapat L, dapat L per T. Betul ke salah equation?
Salah.
Equation akan jadi salah. Maksud saya, ya.
Sir, yang 1/2 tu tak kisah kan? Sebab dia tak ada dimension kan?
Yes. Okay.
So tulis 1/2 L.
Bukan 1/2 L, tinggal saja.
Oh,
tak perlu, dia tak ada.
So potong lah.
Tu tak ada. Yes.
Okay.
Okay, so L di sebelah sini. So S0, X0 memang L. Ada masalah. Okay, tambah dengan V0 T. So V0 ialah speed. Speed ialah L per T. So kali dengan T. So T dengan T potong. So dapat L. Yang ni yang kedua, 1/2 AT squared. So macam Abu cakap tadi, 1/2 tak payah. Yang kedua ialah L per T square. Ni untuk mana ni? Yang ni. Okay. Tengok tu. How about T square? So T square kat ujung. So therefore kita potong T square dengan T square potong. So therefore kita dapat L equals to L plus L plus L. Nampak? Semuanya ialah L. So that's why this equation is correct. Dimensionally correct. So tapi nak tulis dia tak boleh lah. L equals to 3L. This is wrong. Tak boleh tulis macam tu. Okay, tulis the L equals to L. Then itu maksud dia. Tapi kalau contoh dia, saya keluar satu equation V equals to V naught plus AT square. Okay, kita cuba buat. So V ialah apa? L per
T.
Correct. So yang ni pun L per T. So ini
So
betul. Okay. Plus dengan L per T square. Yang ni T square. So kita akan potong T square dengan T square. So dapat L over T. So sepatutnya kalau equation ni betul, yang sebelah selepas ni mesti L over T. Tapi dia dapat L saja. So definitely this is dimensionally inconsistent. So that's how you show and you prove. So bila diminta show that, maksudnya kena tunjukkan. Kadang-kadang soalan ni pun boleh juga dia nak mention, dia nak, macam saya cakap, how dia nak dapatkan units dia. Macam mana nak dapatkan unit? Okay, maksud dia they will use the equation. Contoh dia, equation yang asal V equals to V naught plus AT. So soalan dia minta what is the unit of A. Kalau by right kita tahulah kan, unit dia mestilah ms negative 2. Tapi macam mana kita nak tunjukkan? So kita buat macam mana? So A ialah V minus V naught over T. Okay, so L over T.
L over T.
Okay, L over T tolak L over T over dengan
T.
So L over T ialah still dapat L over T. Bukanlah kata kosong, maksudnya unit dia nanti kalau kita tolak pun kita still akan dapat unit dia. Bahagi dengan T lagi satu,
L over T
end up dia
square.
kita akan dapat L over T square. Bila kita, ni baru dia punya dimensional. Bila kita convert kepada unit, dia akan jadi M per
S
S
square.
So that will give you the final answers. So that is dimensionally consistent. Itulah dia. So far ada soalan tak? Kat situ. Okay, so then our presentations. Okay, so that is how you do the dimensional analysis. Okay, and hopefully just try how to do the unit conversion. Okay, do not a normal unit conversion, not just for meter to kilometer. That is quite simple. Do it like this question: 14 meter per second square into kilometer per hour square. So try to do it properly, try to do it in a correct way. Okay, I may suggest you to use whatever Dr. Iqbal said in the video about using the bracket. Okay, use the bracket wisely. Make sure you cancel out from at the top to the numerator to the denominator. Okay, you cannot cancel side by side. You must cancel it numerator and denominator. Yang atas dengan yang bawah. Okay. Lagi satu dia highlightkan pasal apa lagi? Significant figures kita dah sentuh. Okay, order magnitude. Then it's done. Right, so have you watched another videos yang lain yang Madam Juliati?
Yes.
Okay, kalau tak pun kita cuba play sekejap dan kita cuba highlightkan apa yang penting ya. Saya tak nak view sangat. Okay, kita play Madam.
Assalamualaikum and salam.
Cepatkan.
And unit 0.9 is a vectors. So the learning outcome for vectors. So the first one here, define.
I think some of you already learned the vectors using in your school days, especially in the form 4 physics and also at maths. But there's some a different approach. Maybe the NMAX approach is you want to find the answers, but in the physics approach, we actually want you to do yes, of course, the answers, the final answers, but we want to know what is behind the vectors. Okay, so you must know how the vectors works. Okay, continue.
Scalar and a vector quantities and unit vector in Cartesian coordinates. And then number 2, explain vector addition and subtraction, operation and their rules. You only have one direction. Vector motion. So in one-dimensional motion, so for example, you only have one direction. Okay, so vectors were used to a limited extent. So for more complex motion, so this one is regarding to 2-dimension or 3-dimension. Okay, so manipulating vectors will be more important. Okay, so here is a vector versus scalar review. So a vector quantity has both magnitude, or we call it as a size, and also direction. Okay, for example, here is a velocity, okay, displacement. So for example, here is 10 feet north. So 10 feet here is regarding to the magnitude, and north here regarding to the direction. Okay, and then force and also magnetic field. Okay, a scalar is completely specified by only a magnitude, or we call it as a size. So for example, here is a speed, distance, and height. For example, if you have a 20 meter per second, so it means that here 20 meter per second is regarding to magnitude. Okay, so here we going to the example here. So here you have two car, okay, car 1, and here you have car 2. Okay, so then I choose to the right should be positive direction. Okay, so here car 1 traveling at positive 25 meter per second, whereas car 2 traveling negative 25 meter per second. Okay, both car 1 and car 2 have the same speed, okay, the same magnitude, but different direction. So indicate that is a negative. Okay, so vector notation. So when handwriting, use an arrow over the letter. Okay, for example, here you have A here. Okay, so A here and then this arrow indicate A here is a vector. Okay, so when printed will be in the bold print with an arrow. Okay, so this one when you're dealing with the computer. Okay, so when dealing with just the magnitude of the vector in print, an italic letter will be used. Okay, but common A here. Okay, two
Okay, I'll
vectors
do
are
some
equal if
speeds.
they have the same magnitude and the same direction. Okay, so moving a vector from one point in space to another doesn't change its magnitude or its direction. Okay, so for example, here you have 4 vectors. Okay, here 4 vectors are equal because they have equal length. Okay, all of this one is an equal length and same direction. Okay, even though 4 vector here is different location. Okay. Okay, so here you have a vector A. All vector A here have the same length. Okay, so same direction. Also, speed must be the same. Okay, geometric method. So you have 2 methods. One is a geometric method. So basically, geometric method use scale drawing or graphically. And the second method, we call it as algebraic methods. So basically, this one is the resultant vector, or this one, the sum of resultant is denoted by a symbol R. Okay, so here if we want to calculate the resultant of vector A and B, so automatic resultant is equal to vector A plus vector B. Okay. Okay, adding vector geometrically. Okay, so basically we use a triangle or polygon method. So first one, you need to choose a scale. Okay, if you have in unit cm, so easy for you. But if you have in unit meter or in unit feet or any unit, you need to convert. Then you need to use a scale factor. Okay, common axis. Okay, so this one should be your x-axis. This one should be your y-axis. So draw the first vector with the appropriate line and in the direction specified. So with respect to the coordinate system. Okay, and then draw the next vector using the same scale with the appropriate line and in direction specified with respect to coordinate system. So whose origin is the end of the first vector and parallel to the ordinate system used for the first vector. For example, here, if you have a first vector here, this one my first vector. Okay, to draw a second vector, okay, I need to use axis at the tip of my first vector. Okay, for example, my second vector, okay, my second vector is going downward. Okay, so means that here from this axis, my second vector is going downward here. Okay, so
Okay, let me stop you from the video. All right. Okay. Boleh faham ke?
Boleh.
Boleh.
Okay.
Boleh.
I know some of you already learned the vectors, especially how to deal with vectors. So the unit vector, of course, will involve. I still believe that some of you maybe have already tried or maybe not encountering the vectors problem, because vector is very simple, but very hard to understand if you don't put yourself into the systems of vectors. So of course, if you want to solve the vectors, okay, like the madam said that the vector should be, if you want to deal with something, sir, of course we want to find the resultant of vectors. How to get the resultant of vectors? First is geometrically. How to use it geometrically? You use a drawing. Use a drawing. Okay, what type of drawing we are talking now? First, we must do it in the you have two methods. First is tip to tail method. That's what we call as tip to tail method. So what is tip to tail method? So let me show you some examples of tip to tail method. Forward. Kejap ya, kejap. Okay, can you see it? Yeah. So you must present your vector with the arrow. So mesti ada topi di atas kepala, sebab dia ada banyak cara lah nak tulis vektor. Ada guna italic kan, tapi takkanlah semua vektor kamu, tulisan kamu dah lah italic juga kan. So susah nak apa panggil nak konsisten dengan italic tu. Okay, so nanti orang akan confuse. So we must put the arrow. Letaklah arrow di atas that vector. Okay, so this is adding geometrically. First, using the tip to tail method. So tip to tail method is how you do like this. Okay, graphically. So let's say if you do have vector A. Okay, tengok kat bawah ni ya. This is vector A, and you have vector B. Okay, so vector A plus vector B is called okay. Let's see if you do have vector A. Okay, and then you want to add with another vector B. So what is tick to tail method? So tick to tail. Okay, this is one way to produce a resultant vector. So first you do A, so meaning that from okay, with the correct value, the correct magnitude, and of course the correct direction. And then of course at point A, at the end of point A, or at the end of point vector A, which is here, you put the vector B, okay, with the correct magnitude. And so this is vector A and this is vector B. And what is the resultant? Resultant is taken from the first point of the first initial point of vector A until the final point of vector B. So meaning that this is the resultant vectors. So this is known as R. Okay, so this vector A, so we are saying that vector R is equivalent to vector A plus vector B, equivalent to R. And we have another one, which is what we call as parallelogram. How to do a parallelogram? So this is parallelogram. Ni dulu kita buat macam mana? Kita buat A. How to do B? Okay. Instead of put at the end of A, kita letak dekat the beginning of A. Kita letak B dekat sini. And of course, the parallelogram is what we must extend. Okay, do a extension to this part, and you draw the line from the beginning of both vectors. So that will be C. And of course, if you are drawing a vector, you must use, not just like me, you must use a scale. Use a ruler, okay, to draw this one. I just want to show you. Ada juga ni, tapi biarlah, kan. So you must use ruler. You must use so you can see, you can have two exact answers using the two different methods. You're using parallelogram, of course, the tip-to-tail methods. Personally, I do like to use a tip-to-tail method. Okay, but if you want to wish, because parallelogram is very specific. Of course, when you do have two vectors, yes, you can use parallelogram. But if you do have more than two vectors, vector C, vector D, then of course you will find parallelogram is quite impossible to do it. So you must use a tip-to-tail method, because tip-to-tail method, any values. Okay, let's say you put A, you have A, you already have B, now you want to plan C. Ada C pula naik ke atas. So what is vector D? Atau what is vector resultant from here to here? So that is vector D. Okay, ataupun resultant vector untuk A, B, C tambah. So if you do have two or more vectors, two vectors or more, make sure you use the tip-to-tail method. Remember, okay, what is tip-to-tail method? Is in the the function of this method is to find the resultant. Okay, how to get the resultant vectors using the adding in terms of components. So let's use the component. Okay, let's watch how the method will say about components.
This vector tail to the end of the last vector. Okay, so means that here my resultant coming from this one should be a tail. This one should be, if you want, because I assume this one my first vector. If you theta is regard a scale. Okay, then second, I need to draw vector 1 from this to the position here. So this one should be added graphic and resultant. So this one vector B, if the tail of the first vector to the tip of the last vector, means that here this one should be your resultant. So this resultant, okay, and this resultant, so basically the same resultant, means that the same length. Okay, so if you want to find the angle here, so due to the to this resultant. So this one should be your theta. Okay, and this one also. Okay. Okay, if you have one, add the negative of the sub B so the direction of the result is the same of the original vector. Assalamualaikum and salam sejahtera direction. Okay, and then positive 25 meter per second, whereas car 2 traveling negative 20. Assalamualaikum and salam vectors. And the last one, discuss the
So
various
this one is the adding the vectors in terms of components. So we do it. Just watch the first. So maybe have you watched this one also?
Yes.
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 Yes, sir.
Yes.
How you may find the questions? Is it okay, or do you need me to?
It's
Okay.
like math.
It's like maths, right? It's quite simple. It's very simple, but maybe for some of you, you did well in that maths. It's okay, but for those of you who are still merangkak-rangkak, so this part where you must do it properly, because if you want to add the vectors using geometrically, meaning that using a tip to tail methods or maybe parallelogram, like I used to say just now. So it is very important for you to understand that the value is based on your drawings. So if you base on your drawing, you must know that your drawing, you must use a perfect scale. You must use the correct scale, or maybe a representation of the scale. You must use correctly, because all value will depend. But if you want to add the vectors, or you want to do resultants of the vectors using the components, so you must look at this video properly. Okay, the next video. Okay, I think you have watched the video very good. So I just want to highlight the things that you should know about looking at what should the important things are using
forms
the
of writing unit
components.
vector,
Okay.
such as X, Y, and Z, and I, J, K. So basically,
Okay, we
this
have
one
a unit
depend on the
vectors of
textbook. Okay, for
X,
your
Y, Z,
textbook,
I, J,
basically we
K.
are using X, Y, and Z. Okay, so here resolve vector into perpendicular components using a two-dimensional coordinate system. So basically, two-dimensional here is regarding to X and Y coordinate. Okay, so here you have axis here. Okay, so you have a vertical one here. This one should be Y axis, and the horizontal one here, this one should be X axis. Okay, when you look at this diagram, so here you have a vector A, okay, a vector A at an angle theta. So here your theta here respect to X axis. So means that here, if you want to find the component of vector A, so you have two components. So the horizontal one here is regarding to AX component, and the vertical one here is regarding to Y component. Okay, so these are the projection of the vector along the X axis and the Y axis. Okay, so the X component of a vector is the projection along the X axis. So means that here your AX is basically is equal to A cos theta, and the Y component of a vector is the projection along the Y axis. So basically AY is equal to A sin theta. Okay, so remember this one. Okay, so this one from your mathematical class. Okay, so sin theta, okay, it's basically is coming from opposite over hypotenuse, right? Whereas cos theta, okay, is basically coming from adjacent over hypotenuse. Okay, when you look at this diagram, so here you have vector A, okay, vector A at an angle theta. So now your theta here respect to X axis. Okay, so So means that here, if you want to find AX and if you want to find AY, so this one is a common formula. Okay, so you know that this one should be your adjacent. Okay, this one should be your opposite, and this one should be your hypotenuse. Okay, so if you want to find AY, so how do you find AY? So means that here AY in part of opposite, right? So of course this one you can use sine, okay, theta is equal to opposite over hypotenuse. So your opposite should be your AY and your hypotenuse is your vector E. So means that here if you want to find AY, so automatic AY is equal to, you bring this side, A sine theta. Okay, same goes to this one. Okay, so now you want to find AX. What is your AX? So AX in line of adjacent, right? So adjacent of course this one should be cos curve. Cos theta is equal to adjacent over hypotenuse. So your adjacent should be your AX and your hypotenuse should be your vector E. So means that here if you want to find AX, automatic AX is equal to, you bring to this side, it become A cos theta. Okay, so now if you want to find the summation of component of vector E, okay, so automatic vector A is equal to component of vector A, I mean this one is AX plus AY, okay. Okay, so here given the magnitude and direction of a vector, so find its components, okay.
Okay, I will stop you here. I will stop you there so that I can show you the that will be the highlight of this chapter, which means the first one you do understand. You have already learned about the significant figures. Sorry, I mean the base quantity. Okay, from the base quantity you learn about the derived quantity, and of course you learn about dimensional analysis. What is the functions of that dimensional analysis? You should know. Okay, to see the consistent or inconsistent of the equations, and of course the last part is to get the USI unit. And you already you also learn about learning a significant figures, decimal point, for you to understand the concepts when you do a subtraction, addition, multiplication, and divisions. Okay, and then you learn about converting units. Okay, how to convert units, and of course the vectors. Okay, so first is using the vectors. Okay, how about the vector? So you know the notations of the vector. Okay, you also learn about how will you get the uh, resultants of the vectors. So first resultants of the vectors is using drawing. So using geometrically. Okay, geometrically using drawing. So you must use the either tip to tail methods or parallelogram. And of course, the last part will be using components. So you have at least covered until using components. Okay, but we still have not much time of how we can use. So maybe we can discuss later. You can discuss more in the tutorial class. Okay, you can discuss more in your tutorial class. Okay, how to do it. I mean, you can see, you can watch the videos. You can watch the videos until the end to understand the concepts of the vectors when it comes to how they get the resultant vectors using component. That is very important. And of course, that is the most accurate one compared to drawing. Okay. So I think that's all for today. So this is basically, and we will continue our lessons next week. Maybe I will touch a little bit in terms of component vectors. Okay, and of course we will continue back And of course afterwards you can still you can start the tutorial 1 already. Okay, we already achieved the targets for you to understand. If you wish to meet to to explain more in terms of material in tutorial 1, you can ask me anything. Okay, no problem. Okay, I may take one questions if you do have a questions right now.
Sir, I have a question about the unit conversion.
Okay.
I want to ask about the first question that the sir asked when the change convert meter per second to kilometer per hour square, right? Sir, the acceleration, right? The first one, meter to kilometer, I understand, but the second square to hour square, why do we need to square the 3,600?
Okay. I think let me put you one. Okay, because that will be the questions where it's actually based on this part. That's one.
Yeah.
Okay, because 3,600. Yeah, you see here, AB square, where you have two things inside a bracket, that square, you must square everything inside the bracket. So A must be square, B is also square. So that's why 3,600 is also square, because this is basically 3,600 square S square. 3,600. It's not just 3,600, but when we put in the bracket, we must know everything in the brackets should be square. So 3,600 pun square, second tu pun square. Jadi yang kita potong dengan bawah ialah S square. Okay?
Okay.
Faham tak? Cuba tengok dulu. Ni you boleh snap dulu benda ni, and then you boleh try it out. Okay? Okay. So I think that will end our discussions. Okay. So thank you very much, everyone. Thank you for your attention. So I'll see you next week. I think with the new link, so that you don't have to, kalau link ni kamu kena masuk sama juga kan? So kita akan ni dululah.